Hello again. Now, let's look at problem 8.10. Show that if AB equals CD and AD equals BC, then ABCD is a parallelogram. So, let's draw our four-sided figure. Make it look somewhat parallelogram-ish. And so label the points A, B, C, and D. And AB is the same as CD, and AD is the same as BC. Now, in order to show that ABCD is a parallelogram, we need to prove that the opposite sides are parallel. Once we have done that, we can complete our proof. Now, to show that lines are parallel, we have to show that one of those parallel line properties are true, like the fact that alternate interior angles are congruent, or that same side interior angles are supplementary, or something like that. Well, in the previous problem, we showed that the angles like A and D were supplementary to each other. So maybe if we can show something like that, we can get our proof. And when we want to show that stuff is equal to each other, we use triangle congruence properties. So let's make a triangle out of this problem, and maybe we can figure out what we're dealing with. So if I can split this triangle up into two parts, where we have two triangles, ABD and BDC, well, it's pretty clear I have side-side-side congruence. So triangle ABD is congruent to triangle ABD, so that would go with CDB by side-side-side congruence. Now, how does that help us? Well, it shows that the corresponding parts of the congruent triangles are congruent. So, this angle right here will have to be the same as this angle right here. So, angle DBC, no, not angle DBA, sorry, is congruent to the angle BDC. And that's by that property CPCTC. And, well, we don't even have to go much further, because we have already shown that AB must be parallel to DC. Because in this diagram, we have that alternate interior angles are congruent. The angle DBA and BDC are on the interior of the lines AB and DC, and alternating sides of the transversal BD. So we have already shown that the lines AB and DC are parallel, because alternate interior angles are congruent. So that's one half of our proof. Now how do we find the other part? Well, if we use the fact that these two angles have to be the same, So ADB and DBC. Well, notice they're on the interior of the parallel lines AD and BC, and they're on opposite sides of the transversal BD, so we have the same thing. So angle BDA is congruent to the angle, not triangle, the angle DBC, and that's also because of CPCTC. So therefore, we have that AD is parallel to BC. Again, because of alternate interior angles. And I'm not going to write the full reasoning out because it's the same one that we used over here. And that completes our proof. So, one thing that we have shown is that if opposite sides are the same, then we have that ABCD must be a parallelogram.